There we go. So, apologize for the growing pains here to get this started. And my name is Stuart Creek. I'm with Simplilearn, and we are the delivery partner for the Caltech Center for Technology and Management Education's Data Science Bootcamp, among other programs we deliver for Caltech. Today we're here to do a free sample class from the curriculum of the Data Science Bootcamp on inferential statistics. And we're here with one of our most senior instructors, as I mentioned, Shubham Pandey. He has, let him introduce himself a bit more before he gets into the lesson. 11 years of experience in data science, has facilitated workshops for a number of Fortune 500 companies, as well as universities and training institutes. Strategy consultant in the field of data science, including in statistical modeling and machine learning. So he's very well qualified to bring you an industry perspective on this as part of his instruction. And we'll talk about the curriculum of the Data Science Bootcamp. We'll do some script or background on inferential statistics, why it's important, and then we'll get into the live lesson and we'll do a recap. So I want to just say the Caltech Data Science Bootcamp is a comprehensive program that takes you from the very basics to a practical capability instead of skills around data science. Start off with statistics and then move into R and Python programming, applied science with Python, machine learning, Tableau for visualization. You sum it all up with a capstone project where you apply all of those skills that you've learned in the program into one industry aligned project that becomes the jewel in your portfolio that you can proudly show off to people as your experience and your set of new skills demonstrated. Plus you get access to the electives at no additional cost. Based on your interest in your schedule, you can take business analytics, Excel, SQL training, Power BI, and then master classes from Caltech faculty. So you can get pretty far into data science and machine learning through this program. And I will turn it over to Shubham to tell us a bit about inferential statistics.
Hi, Stuart. And hi, everybody. Thanks for having me here. Let me share my screen. Very good evening, good morning to all of you. So very excited to talk to you here on YouTube Live, first YouTube Live this year for me. And I'm pretty excited to meet you all. And I hope you all are equally excited. Let's get going. Let's get started with inferential statistics. So, do you see my screen? My screen is visible?
Yes, it is.
Great. So this is the LMS, Simplilearn LMS, Learning Management System. So I'll go to my courses and then I'll come down here. Here I've got Caltech Postgraduate Program in Data Science. I'll click here on Program, and here it takes me to all these courses. It starts from Statistics Essentials, and then Python, then Applied Data Science and all. and then at the end Tableau and Capstone projects. We want to discuss here something related to statistics. So I'll go to data science. I'll click here. So this LMS, for your information, it's a one-stop shop for all your learning needs. Here you'll find all the content, all the self-paced videos you'll find here, assessment, your attendance will be here only. You'll be able to join classes from here. So one-stop shop for you. And here I'll go to practice lab. So this practice lab is a cloud-based lab. And I'll be able to write Python codes here on Jupyter Notebook. So I'll launch lab. Here you go. It takes some time to get started.
One of the good things about this feature is that you don't need to set up an environment on your local machine because it's available through this virtual environment, correct?
Absolutely, Stuart. And second thing is that in your real life work, whatever organization people join over there, most of the time they'll be working on cloud-based tools. So when we promise that we create industry-ready professionals, it is also one important point we take care of. So let me open here statistics fundamentals. So the topic which we are going to discuss today is a very fundamental topic, but very interesting. So first of all, let me set the agenda here. We'll be first of all learning what is statistics. A little understanding about statistics will develop. We'll look into the types of statistics. We'll understand descriptive statistics briefly, inferential statistics briefly, and then we'll be discussing one case study we'll go through, because I think that will be fun for you. You would always like to understand the application part, where statistics will be useful for us. So we'll be discussing one case, we'll have some chat, we'll have some discussion. Feel free to ask your questions, feel free to share your thoughts, share your ideas, and let's have fun in the remaining part of the session. Yeah? Ready to go? Great. So statistics. I would say for a data analyst, it is very important that one masters tool. In terms of tool, that may be Python, that may be R, that may be SAS, or any visualization tool like Tableau, Power BI. So tools, and then after tools, it is about domain knowledge, it's about industry knowledge, it's about the knowledge of the area where you want to apply it. And the third point, which is something we are going to discuss here, is statistics, the techniques part. So in techniques, statistics, applied statistics, these are like very, very important for us. So what is statistics? Statistics is a discipline that deals with methodologies to collect data. Data collection is very important. Collecting data from different sources. Data sources may be different servers. Data sources may be data warehouses, social media platforms. Data source may be an Excel file as well. Okay, so you need to know how to collect the data from different sources and what to collect depending on the problem you're solving. After you collect your data, data may not be in the format which is suitable for further analysis. So what you do, you prepare your data, you prep your data for future analysis, further analysis. And after that, you do the analysis. In analysis, you come across different types of analysis. And after you do the analysis, the next part is interpretation. Whatever number you have come up with, that you should be able to interpret in perspective. You should be able to interpret the numbers in perspective of the business situation. So these all steps, when you perform, you need statistics. Okay. There are common terms used in a statistic like population, sample. So population is the complete data pool from where a sample is drawn. Population is that set of objects around which you make a decision. And sample is a part of the population. Sample is the subset of the population, which you always try to make as representative of the population as possible. Then we have measurement. A measurement is a number or attribute calculated for each member of the population or sample. Sometimes this is referred to as summary measure. Sometimes it is referred to as metric, parameter. Okay. We come across variables, and we also look at the distribution. So we don't have enough time to go through all these in detail. In our live classes, we actually go through all these things in big detail with the help of different examples, with the help of different cases. But here we are meeting for inferential statistics. So types of statistics, we have descriptive statistics, inferential statistics, predictive statistics that can also be considered as a part of inferential. So as the very name suggests, what is descriptive statistics? I think you should be able to understand the idea about it. What is descriptive statistics, by the way? What do you think is descriptive statistics? Which helps you describe, which helps you characterize. Absolutely. Thanks for your responses. So like when you meet any individual, what you do, you try to describe that individual. You try to characterize that individual based on various parameters, based on education, ethnicity, based on physical appearance, based on the language, etc., etc. The same way, a data analyst, a data scientist should be able to describe data. Okay. Data is described based on summary measures. I talked about that a couple of minutes back. So we use measures of central tendency, measures of position, measures of dispersion. You all must have used mean, median, mode, standard deviation, variance, etc. So these all are used to describe your data. Okay. Inferential statistics we use when we need to draw conclusions about the population, when we don't have access to the whole population. We are not able to reach the whole population, it is too big. Or there are other obstacles having the whole population with us. It is difficult to describe the whole population. In that scenario, what we do, we don't hold back. We don't say that we can't do the analysis. What we do in that scenario, we take a small part of the data. We extract a small part of the data. Absolutely. I agree with you. Thanks for your response. Folks, please keep responding, keep interacting. Let's have fun. Let's not make a monotonous one-way communication. Let's interact. We are meeting for the first time, I think, right? So let's have fun. Keep asking questions. So inferential statistics, again, the very name, if you look at, it is about making inferences. So what you do when you don't have access to the whole population, you work with the sample. You collect a sample. Yes, when you collect the sample, you have to be careful. You try your best within the constraint you're working, because you always work under different constraints. Budget constraints, resource constraints, time constraints. So within the constraints, you try to have your sample as representative as possible of the population. After collecting your sample, you perform the analysis based on sample. So with the help of sample analysis, you try to make inferences for the whole population. That's what you do in inferential statistics, basically. So here in inferential statistics, you work under uncertainties. It is not a deterministic way of calculation. So you come across terms like random variable. So we do the analysis of random variable here in inferential statistics. Okay. Inferential statistics allows us to do estimation for the whole population. We can do the estimation of the population mean. We can do the estimation of other population parameters with the help of a sample analysis. Okay. So for estimation, we use a special statistic like Z statistic, T statistic. Okay. After estimation, if I look at the application of inferential statistics, we come across hypothesis testing. So we'll talk about hypothesis testing as well with the help of some examples. But any questions so far with whatever we have discussed? Anybody? Feel free, please. Awesome. I know, and you also know that we are not delving deeper into any concept because we have time limitation here. But I'm trying to give you an idea about statistics, inferential and descriptive statistics. Okay, can there be a point where you drop assumption? Yeah. We need to sometimes use assumptions to come up with good results. Okay. But we should know what we are doing. That is important. So that we can make the decision correctly. So yes, we need to make assumptions, and assumptions are made in all the types of sciences to get to the possible, to get to the best possible results, right? And then we take care of the reality as well later on. Okay. Let me take up a couple of more questions. Which were the two descriptive statistical applications you mentioned when collecting a sample? So when you collect the sample, you don't use descriptive statistics. I only talked about the importance of collecting sample. Okay. Once you have your sample, once you have your population, then you perform descriptive or inferential statistics. Okay. What I mentioned while collecting your data, I told you that you have to be careful when you collect your data. Because you need to make your sample as representative as possible of the population, because ultimately you make your decision for the population. You don't make your decision for the sample. So you just don't go and select anything. You need to be careful. You need to take care of the fact that the sample should be a good representative. Absolutely. There are a set of questions which we need to answer, which we need to address before we collect the data. And that's why we have different types of sampling techniques as well. We have probabilistic sampling techniques, non-probabilistic sampling techniques. We have simple random sampling, systematic sampling, stratified sampling, cluster sampling, and so on and so forth. So different types of sampling techniques we have, and we choose the technique according to the constraint we work under, according to a business requirement, according to different other aspects. Okay, because ultimately everything depends on the sample. That is the basic premise. Your whole analysis is based on that only. I hope I addressed your question, right? Great. One important term, very interesting term here we have predictive statistics, which helps us to do predictive analytics. So what we do in predictive statistics? What do we do in predictive statistics? How does that help? Nice. Thanks for your responses. Absolutely. Absolutely. I agree with you. But let's not limit it to forecasting. So when you come up with future numbers, you call it forecast. If I talk about predictive statistics, it's more about, if I summarize it, if I make it very simple for you, it's about estimating the unknown. It's more about estimating the unknown. If that unknown is in the future, we call it forecasting, right? So it's all about estimation. And we spend a lot of time in our course to learn predictive analytics. Absolutely. Thanks, folks, for making this session so interesting. To estimate what could come next. Absolutely. I agree with you. But this estimation is not random. It is not a random guess. It is calculated based on statistical significance. So statistics helps you to do the estimation. It helps you to calculate the risk. Nobody has seen the future, and statistics does not let you see the future, but it definitely helps you to measure the uncertainties to some extent so that you can take better decisions. That is the whole idea, right? Great. I appreciate your questions here. Okay. We learn here data categorization, types of data. So these details, I'm not getting into that. They may not interest you at this point of your learning. Too much of mathematics, too much of theory, you may find it as. So I'm kind of skipping this all. Let me open advanced statistics and talk a little about hypothesis testing. Hypothesis, you understand this term hypothesis. So these terms, if you remember, I mentioned t-test. Hypothesis, this term hypothesis, you understand? Let me get into my OneNote. What is hypothesis? Do you see my OneNote where I'm scribbling? Great. So let's set some background here for hypothesis. Yeah, nice. So let me tell you, in our world, any statement which is not proven by statistics, which is not backed by facts, that remains hypothesis, that remains an assumption. Until proven statistically, that remains an assumption. Okay. So nowadays, all the businesses are driven by, I would use the term driven. They are driven by analytics. They are driven by data science. Okay. So you just can't do anything based on your gut feeling. If you are feeling, you have some feel, I mean, some intuition you are getting, or you have some other calculations and you think this calculation may be correct in this business scenario, you need to check that, you need to test that. So hypothesis testing becomes a very important technique. So hypothesis testing helps you to test your hypotheses. Hypothesis testing helps you to perform some advanced analysis as well. Okay. In fact, if you start with any new problem, if you start with any new data, it is very difficult to take the very first step. Very difficult it is. How to start from? It is always a big question. Okay. So how you start? You start by testing your hypotheses. Suppose you come across the sales of different products and you find that sales for a particular product has come down in the quarter as compared to previous quarters. Significant reduction in the growth in the sales figures, if you find that. Now, you would always like to delve deeper. You always want to understand the reasons. Why such a drop in sales? Okay. So sales might have declined because of several reasons. There may be economic reasons, political reasons. Sales might have come down because of incompetent product, because of product packaging, because of incompetent sales organization, because of ineffective marketing, because of bad after sales services. There's so many reasons. You always get kind of flummoxed as to where to start from, right? So you create all your hypotheses. What may be the reason? So you just write down all your hypotheses and then you brainstorm amongst your team members what they think about it. Sometimes you may have to talk to your client and understand what they think about the problem. You may also have to go for focused group discussions and try to understand what others think. Bringing in external perspective is also very important for any problem solving for that matter. Okay, so all in all, what you do, you first of all collect all the hypotheses, all the alternatives which you think may help you solve any problem at hand, and then you start testing. While testing those hypotheses, you come across amazing results, and sometimes that lead to, while doing hypothesis testing, you get led to some amazing further analysis, further uh, deep down analysis, and you come up with great relationships, great patterns. Okay. So I think now you understand the importance of hypothesis testing. And if you don't know hypothesis testing, it becomes challenging for you to learn advanced techniques like regression, logistic regression, time series analysis. Everywhere you'll use this. So hypothesis testing in itself is a very important technique, and then it is used in other techniques as well. Okay. We will get an idea about hypothesis testing with the help of one example. Okay. Let's start with a case related to a credit card company. Let me ask you a question. What do you think is the main source of income for a credit card company? What is the main source of income for a credit card company? Tell me. Thanks for your responses. A lot many responses this time. That's good. I always knew that case studies interest you. And that's why in the classes, I make sure I discuss every concept with the help of cases, with the help of case studies, because ultimately you learn all these things so that you can do the application effectively. uh, so very interesting answers coming up. Isn't it fun? Great. So late fees, interest fees, they make money from sales. Broke people, very interesting. Let me tell you, majority of the revenue a credit card company gets from interchange fees. You understand interchange fees? Interchange, yeah, great. So when you make any transaction at a merchant location, some part of that transaction goes in the pocket of the credit card company. It's a complex phenomena. It is not that straightforward. There are multiple entities involved, but I'm making it simple for you. There are acquirers, channel partners, and then issuer bank is there. So multiple entities are involved, but I'm making it very simple for you. If you go to any merchant, say you go to Walmart and swipe your card for $100, say around $2 will go to the credit card company. So that is a very significant proportion of their revenue. All in all, what I want to convey to you here that merchants are very important for a credit card company. So a credit card company runs its business in two directions, B2B as well as B2C. B2B means when they do their business with merchants directly, and B2C means when they do their business with end customer, end card holder, end card member. Absolutely. So both the parts of both the types of businesses, both the sides of the businesses are very important for any credit card company. So merchants are also very important. It is important for a credit card company to ensure that their merchants are satisfied. Their merchants are kind of delighted merchants, right? Delighted customers. Every company aspires to have their customers delighted, right? And it is important that they measure their satisfaction. They measure how their customers, how their merchants are feeling about the company. What are their sentiments? And for that purpose, periodic surveys are conducted. There are different types of surveys. And in those surveys, sometimes a very important question is asked, how likely you are to recommend my product, my services to your friends, to your colleagues. Have you ever come across such question in any survey? I'm sure you must have. Yeah, I knew. So with the help of this question, actually a very important metric is calculated. Across industry, this metric is very important. The name of this metric is NPS. What is NPS, guys? So there are ways to make people answer the surveys, right? So you have a point. There are methods to make people fill the survey. You can go for Google or Chat GPT is also there to help your cause, right? In the morning, one of my students shared with me one poem on machine learning. At first instance, I thought like it is something actually written by that student. Then I realized, oh, it is Chat GPT. Okay, so coming back here. NPS, yes, absolutely. I got many responses. Net Promoter Score. So when that question is asked as to how likely you are to recommend the product or service to your colleagues, to your friends, to your family members, etc., you're asked to rate on the scale of 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If somebody is giving 9 or 10, that person is considered to be promoter. And if somebody is giving anything between 1 to 6, that person is considered to be detractor. And for 7 and 8, passive. Percentage promoter minus percentage detractor. This gives you NPS. So basically, NPS is used to understand customer sentiments. It is considered to be a very important metric. And rightly so. Don't you think so? If somebody is ready to recommend your product, if somebody is willing to recommend your services, your product to other people, it means they're actually happy. Am I right? Common sense should prevail, right? So NPS is very helpful. So I just kind of set up the background here. Now let's come to the real point of concern, the problem. So suppose after the survey, you got data, responder data. In this data, you have name of the merchant, name of merchant, name of the merchant. You've got marketing channel or communication channel, whatever you want to name it. And then we have the score. score to that question? You're absolutely correct, Deborah. I agree with you. Okay. So we've got name of the merchants, marketing channel, and score. I'll make it simple for you. Suppose we've got two channels here, face-to-face, and the second channel is telecommunication. Telecommunication. Now tell me, prima facie, what do you think? Which channel is more effective? Is it face-to-face or telecommunication? So I can see here most of you are responding with face-to-face. And let me tell you, management also thinks in the same way. Suppose I'm sharing one case with you, a business case. Management always had this opinion that face-to-face communication is very effective. When you are sending your representative to meet the customer in person, the level of communication is much better. Merchant is able to share the grievances, the issues easily. And also, the representative of the credit card company, that person, that employee of the company, is also able to communicate effectively different offers, different promotional offers, different schemes, different ways of working, new products, okay, etc., etc. So the communication becomes much easier, much smooth when it comes to face-to-face communication. But we discussed at the beginning, it is only assumption until proven by numbers, until proven by empirically driven methodologies. It remains hypothesis only. So it is a hypothesis. Okay, and that hypothesis has to be tested. Okay. Here, something very important is the first step, which is to state your hypothesis statement. We can't write our hypothesis in English because here we are going to follow a procedure. Here we are going to follow a well-established methodology, and for that we need to write our hypothesis in a very specific way. We write our hypothesis in 2 lines. First line is called as null hypothesis, and second line is called as alternate hypothesis. Null hypothesis is represented by H0 and alternate is represented by HA. I'm gonna tell you something here, one concept, how to write null and alternate, and then I'll ask you a question. Okay, so be ready. Everybody, please listen to me carefully here, because right after this, I'll be asking you a question. I'll be asking you how to set up this hypothesis statement for this situation. Okay, so be very carefully listening to me. In null hypothesis, what we write condition which leads to status quo. And in HA, we write that condition which leads to change. Okay. By the way, what is the status quo? What is the status quo? So if you search for this word on Google, if you look for the meaning of this word, the meaning is existing state of affairs, right? The meaning is existing state of affairs. So status quo is about what is prevalent, what people think, right? What has been the situation, okay, that is your status quo. Okay. So in null hypothesis, what you do, you write that condition which you will get after the analysis, which leads to status quo. So you write here that condition which you may get after the analysis, which may lead to the status quo, that you write in null hypothesis. Okay, so what should be the null hypothesis here? Or let me ask you another way. What is the status quo here in this situation? In this situation, the status quo is people believe that face-to-face is the best way to interact. Absolutely. That face-to-face is better. That people believe. Now, after this whole analysis, which condition, if you come up with, will lead to status quo? Tell me, which condition, if comes up with, will lead to status quo? After doing this whole analysis, which condition, if you come up with, will lead to status quo? Very good. Very good answer. Really appreciate. And I'm very happy to see your responses. It seems like you were actually listening to the whole discussion. So a couple of you answered here very well. Really happy to see your responses. So my time investment is worthwhile here. I'm happy. Very good. So if we write here NPS from face-to-face is more than NPS from telecommunication. In this scenario, let me write it a little more clearly. So in H0, you write here NPS from face-to-face is more than NPS from telecommunication. And in HA, you write NPS from face-to-face is less than NPS from telecommunication. Okay. So if after the analysis you come up with this condition, if you are able to deduce that NPS from face-to-face is more than NPS from telecommunication, what will happen? I'll tell you what, it is interesting. Your management believes that face-to-face is a better way of communication. And after doing this analysis, after spending like 2-3 days, you collect your data, you clean your data, and then you do the analysis. After 3 days, suppose you go to your management and you tell your management that you have done this analysis, and this analysis shows that face-to-face is a better way of communication. You know what will be the response of those people? Come on, why you wasted your 3 days? I was already telling you. So uh, these type of responses you should be ready to hear, right? It was only for fun, but you understand what it means. So people will keep doing what they have been doing. They were investing a lot of money into face-to-face communication. Face-to-face communication requires investment, a lot of investment. While telecommunication is not that costly, it is cheaper, right? I'm happy that you are enjoying the session. Great. But in case you come up with the second one, which you have written in alternate, that NPS from face-to-face is less than NPS from telecommunication, that will lead to changes. And it will be something big. Why it will be big? Because it will impact the dollars directly, isn't it? Because face-to-face is a very costly medium. You are sending your representative to meet the customers. It is costly. And if, despite investing such a huge amount of money, if merchants are not happy, if the customers are not happy, why would you at all go for face-to-face? You would stick to telecommunication. Cheaper and effective, isn't it? Now the next part is, after setting up the hypothesis statement, the next part is testing. Testing requires more in-depth discussion. For testing, you need evidences. And in terms of evidences, you derive a statistical term called p-value. And you compare it with something called significance level. And then you finally conclude which statement is correct. Okay. So this is hypothesis. Any question? I'm pretty much done with the hypothesis testing, whatever I had to discuss. I'm kind of short of time here. Otherwise, it is really fun discussing all these concepts with you, and especially with people like you who are interacting. And I like interaction. Great. Any question if you have, I'm happy to address. P-value requires normal distribution. How you assure a normal distribution? Let me tell you, it is not that straightforward. It's not one-line answer to your question. And here we require the application of central limit theorem. Okay, so with the help of central limit theorem, we try to calculate p-value. Okay. Any other question? So significance level depends from one situation to another. It's a kind of risk appetite. Different people have different risk appetite. Different companies have different risk appetite. You have different risk appetite for different projects, right? Generally, 5% is used across industry, but nothing casted over a stone. Central limit theorem states that many number of experiments lead to, okay. You are very close to what central limit theorem tells you. And if you know central limit theorem, you know that if the sample size is adequate, if you have large enough sample size, then the distribution of sample means will be normal, and that information you can use to calculate p-value. Okay, I'm so happy to see your curiosity, your inquisitiveness. That is the first step to learn anything. So this is the very first step to learn anything, and that you have. So that's great. Yes, absolutely. It also depends on which test it is, whether it is one sample test, it is two sample test, it is three or more sample test, and then whether it is two-sided or one-sided, one tail, two tail, a lot many aspects here. Hypothesis testing takes time to understand. Any other question? I told you nothing casted over a stone, but generally it is 5%. Sure. So Stuart, I'm pretty much done with the agenda, and you can very well take over. And if anybody has any question, I'm happy to answer.
Okay, I'm only jumping in because we are at about the end of the hour we had scheduled for the webinar. So I wanted to cover a couple of things before we leave, but first I want to uh, remind everybody that this is the type of class that you would take within the Data Science Bootcamp. So this is the kind of interaction you have during the live instruction. And there's also a lot of other aspects to the bootcamp, including preparation through pre-recorded videos, being able to review your classes through class recordings, being able to do the exercises on the live lab environment as Shubham demonstrated. So I hope this gave you a flavor of what the course is like. I'm going to just, before we finish the webinar, I just want to cover a couple of quick points about the program and ask you a couple of questions in the audience. So the Data Science Bootcamp is a 6-month program. It's fully online through the learning management system, as you just saw. Oops, my will quit for a second, but it'll be right back, so bear with me. Don't go anywhere, we'll be right back. Something that happens when I switch to screen sharing. Apologize for that. So again, it's 6 months. We say you should devote about 10 hours a week because there's most weeks there's live classes with instructors like Shubham on the weekends, 4 hours Saturday, 4 hours Sunday, plus the integrated labs in between, which you can do anytime 24/7. So you can fit the class homework outside of the class time anytime you have time for it. Pretty much covers everything in any schedule that a working person has. The good thing also about this boot camp is it's open to practically everyone. You only need to be 18 years of age or older with a high school diploma for the educational requirement. We prefer that you have a couple of years of work experience so that you understand the applications of data in the work environment. This doesn't have to be work experience in data processing or data science or data analytics. can be any work experience, but this gives you an idea for the context in which data science is used. And you do have to have some prior knowledge or experience with programming concepts. And as part of the service, also as part of the boot camp, after you complete it, we do provide assistance with your job search. So if you're taking the boot camp to find a new position, you'll have 6 months after the end of the program to access these services. If you're a student in the USA, fortunately, we don't have these outside of the US or Canada, but we do provide other services to help you with your job search. So I want to ask a question of our audience. How much experience do you have? And I'll just ask this quick question. I'll just leave this open for another 10 seconds because it's pretty straightforward. I'll close this in 5, 4, 3, 2, 1. So we have a fairly seasoned audience. 75% of you are out of school, and I assume that most of you who are currently studying are in college or university. So I'm presuming that practically everyone here will be qualified from the education and experience standpoint. Just want to share that with you. And then let's move on. Just so you know, the program is $8,000, but you have a bonus for attending this sample class. Because you were here today, we will give you a $500 discount off of the program fees. And you can also ask your employer if you have a tuition reimbursement benefit at your work. So all of that can help you with this program. The cohort starting May 15th has an induction session tomorrow. But there will be other induction sessions if you can't quite make tomorrow's. And classes start May 15th, and there are also, of course, cohorts starting pretty much monthly after that. So reach out to us at askus@simplilearn.net, and I'm going to put that information into the chat for everyone. That includes the URL for the program homepage on our website. And last couple questions here quickly. So, just to gauge, get a general idea. This is not a promise. This, you don't have to commit, but curious to know who's interested and how soon you'd like to start. I'll leave this open just for another 5 seconds. 4, 3, 2, 1. Okay. Nearly 80% of you, more than 3/4, are interested, and about 30% want to get started either in the May classes or maybe June, July. So again, contact us at askus@simplilearn.net. And last question for you is, do you want us to reach out to you to help you with enrollment, answer any questions, or do you want to get a proof of attendance for this class? And if you answer yes to the question, we will be sending that to you. We'll close in 5, 4, 3, 2, 1. Okay. So for those of you who answered yes, we will send out a proof of attendance, and we'll also reach out to you to see if you have any questions that we can help you with. And with that, we've reached the end of our webinar, our sample class from the Caltech Data Science Bootcamp. Again, you have the URL and the email address, so you can contact us. I want to thank Shubham very much for sharing his expertise and his time today, taking us through the learning experience, teaching us about the fundamentals of statistics for data science. So thank you, Shubham.
Thank you so much for having me here. It was fun. Thank you.
Okay. And I want to thank everybody in our audience today for being here, taking the time to sample the program. And we want to invite you to join our learning community with Simplilearn and Caltech. We hope to see you in the future. That completes our webinar.